So for the next part of the experiment, we're going to be investigating the electric field in this resistor. So to do that, we need to know the voltage drop across different parts of the resistor. We also need to know things like the distance between these contacts, and we also need to know the cross-sectional area of this to find our resistivity. So we're going to use the vernier caliper to take diameter measurement. So you've learned how to use the vernier caliper, so just take some measurements at a few points along the resistor. So you want about 5 measurements along there and record that in a table, get the average and the uncertainty in the diameter. So from the diameter you can get the radius and you can work the cross-sectional area of the wire. What also we need to know is the position along the wire of each of these terminals. So where the wire that comes from the terminal, where it connects with the resistor. So you're going to use a good quality steel ruler to do that. So measure, first of all, where the first resistor is. So from where the terminal touches to where this comes in here. Take a few measurements of that. And again, from here to here, the position of this one. Then from here to here. Then from here to here. And from here to here. So you need the separation of those contacts. So put those into a table and also get the uncertainty in those as well. Remember, you've got a systematic uncertainty in the measurement of from your ruler. You also could get a statistical error by averaging. So every measurement you take must have an error associated with it. So there's no such thing as zero error or zero uncertainty in any measurement. That's a good thing to remember. Okay, so now we're ready. Once we've got all these measurements, we've got the measurements of all these distances here, and we've measured this diameter. We're ready to put some power through our resistor. Okay, so we connect it with our standard resistor in line like this. So you have the red, I usually like to use red cables coming out and black cables going back in. It's a good thing to remember. So we've got a red cable coming out from the positive. Remember, your power supply is off at this point, and we connect it to our standard 1 ohm resistor in one end, out from the resistor into our stainless steel long resistor, and then back out to the supply. But you make sure that you go from the positive coming out to the negative, don't go to the ground. So then we can switch on our power supply. Now, make sure that you can adjust the current here finely. So try not to go above 1 amp. If you go above 1 amp, this guy starts to heat up a little bit, and eventually, yeah, you're going to maybe damage the power supply or damage the wire. So, yeah, you don't want excessive heating in the wire. Now we want to measure. Remember, to find our electric field, we need to know what the voltage drop is across a length of the resistor. So, first of all, let's measure the voltage drop across the standard resistor, this guy here. So, to do that, you can just plug in your multimeter here and here across the resistor, switch it back on, and change to the voltage scale here. So do that a couple of times to get an average value. So unplug them, plug them back in, and take 3 or 4 measurements like that and get an average for the voltage drop across the 1 ohm resistor. So it should be around about 1 ohms. So now we've measured the voltage drop across this resistor. Let's find the voltage drop across each one of these terminals. So we have the position of each terminal relative to the start here. You've got a distance here for the first one. You've got a distance from here to here for the second one. Distance from here to here for the third one. We want to find the voltage drop across each one of those. So, and we can graph that. So we put, first of all, our multimeter on this end of the terminal, and then onto here, and switch it on. So we get a voltage drop across this small length. So take a couple of measurements there, move it to the next section, You get a few measurements there and an uncertainty. You should be tabulating this as well. So have a table, write it all down in there, and keep all your work together so you don't have bits and pieces of information all over the place. It's important to be organized. And then, again, at each position you'll get a value for the voltage drop across that. So now, if you plot that voltage against the position, so each voltage drop against the position of each one of these, you should get a straight line. And from that straight line, you should be able to work out what the electric field is. So it's just a manipulation of the straight line, getting the information out of that equation. Okay, so now you know the voltage drop across this resistor. You know the current flowing through it from here, so you should be able to work out what the resistance of this resistor is. So that's going to give you, well, the beginnings of the relationship between the resistance and the resistivity. So you're going to have measured the voltage drop, so you get the resistance. You have the diameter of the wire, so you can work out what the cross-sectional area is. So you should be able to then go and find the resistivity. You also know the length. So you have that expression at the start of your notes that allows you to work out what the resistivity is. So you should find that, get the uncertainty, because you've taken a few different measurements. They all have their associated uncertainties. You will have an uncertainty in the calculated value that you have as well. So you should be able to work out resistivity and uncertainty, and then compare that against a web browser version of what the value is. So get on the internet, work out what the accepted value for the resistivity of stainless steel is, and see how well you compare. So if you get a value that's within error of the accepted value, you've done well. If you're outside of the accepted value with your error, then that's okay. Just try and explain things that may have affected the result. So there may be bad contacts in here, or there may be other things that you could think of that could have affected the result. So it's important to know in science that it doesn't matter if you fail, it's trying to explain what you've done and why you failed that's more important. And sometimes you can find very interesting things out from mistakes. So just because you make a mistake and it doesn't fit the theory may be wrong. We've got the resistivity of the stainless steel. We've compared that against the accepted value. Now we can look at the conductivity of the steel. So remember, the conductivity is the reciprocal of the resistivity, so it's just 1 over. So you can calculate it that way. So you'll get a value for that. Now, the other way you can do is you can work out, so from the dimensions of the stainless steel resistor and electric field in it, there's another equation that you have that relates the current density back to the conductivity. So you need to go through your notes and work out another way to calculate the conductivity using those things. So then compare that to the value that you've used using the resistivity, the reciprocal of the resistivity, and see they should be the same. So it's always good sometimes to calculate things in two different ways to see if you come up with the same answer. So when you're finished with this, you should be able to include a derivation of equation 4. You should be able to show your demonstrator how you get equation 4 in your notes. You should be able to show this graph of the potential, so the voltage drop as a function of distance. And you should be able to compare the resistivity with the accepted value, and then also calculate the conductivity from that value that you calculated, and then use another way to calculate the conductivity.